Kindly hit the subscribe button. Thank you. Alright, today we are still on the topic separating the variables. Sorry. Separating the variables. Yeah. Okay. Now we have the example there. Example 6.5. Y prime equals to y square plus xy square all over x square y minus x square. We're told to solve this. Alright, solution. You should have known before that your y prime is still the same thing as the y dx, which will be equal to y square plus xy square all over x square y minus x square. Now you've also known that if we should find the factorization here, we have y here, we have y here, we have x here, we have x here. Don't forget, in separating the variables, our y is to be at the side and our x's will be at the other side. That's what we're trying to get at. So we have y square open brackets 1 plus x all over x square open brackets y minus 1. Okay, so after that we can just still rewrite this. It's still the same thing. We can just write it as y square all over y minus 1. It's still the same thing, don't worry. 1 plus x square. Yeah, I'm just trying to make this be at the side and this at the side. It's still the same thing. They are still represented the same way. Now we want to make our y's at the side and our x's at the side. And that means we can just say y square all over y minus, okay, sorry, this will come up and this will be down. Yeah, this will be up and this will be down. That will be y minus 1 all over y square dy equals to 1 plus x all over x square dx. Yes, I hope we're getting that. Now the next thing is we have to find the integration. Yes, integration. You can just say integral of y minus 1 all over y square dy equals to integral of 1 plus x all over x square. Since we've been able to get our y's at the side and our x's at the side, so we applied integration, and based on that we can also say integral, we can just decide to spread this. We can say y all over y square minus 1 all over y square dy equals to integral of 1 over x square plus x all over x square dx. I hope you are getting that. Yes, I hope you are getting that. Now we can now say y here 1, y here will still remain y. Same here, x here 1, x here x. And from there we know that integral of 1 over y should be ln y. Don't forget this one. This integral is also still affecting this. So this is y raised power minus 2. And if we're going to integrate y raised power minus 2, that will be y raised to power, let me do that. Y raised power minus 2. This is y raised power minus 2. We are adding plus 1 all over minus 2 plus 1, which will be minus 1. Yes, plus c. Okay, let's go on. Equals to integral of 1 over x square. Integral of 1 all over x square will be x raised power minus 2. X raised power minus 2. And that is still going to be x raised power minus 2 plus 1 all over minus 2 plus 1. Okay, then plus this is ln this is integral of 1 over x, which will be ln x plus c. Yes, ln x plus c. And after that we can, let me just write everything very well. Then y minus, this is minus and minus, which will be plus y raised to power minus 1 equals to our x raised to power minus 1. That is supposed to be minus x. Yes, this is supposed to be minus x raised to power minus 1 plus ln x plus c. Yeah, so just for the writing's sake, let me just rewrite this as ln y plus y raised to power minus 1. Then that will be ln x minus x raised to power minus 1 plus c. That is it. Alright, so guys, we move on to example 6.6, and that is where we have solve sine x dy sine x all over 1 plus y dy dx equals to cos x. Alright, so the best way to do this is just saying that divide both sides by sine x. What am I trying to say? Sine x all over 1 plus y dy dx equals to cos x. Now let's just say divide we can just say divide through by sine x, and that will be sine x all over sine x 1 plus y dy dx equals to cos x. Alright, from there we can just say sine x cancel sine x. Our aim is to let our y's be at the side and our x's be at the other side, so we can just say 1 all over 1 plus y dy equals to cos x dx. Yeah, I hope someone got that. So 1 over 1 plus y dy equals to cos x dx. Now from there, okay, so sorry, I made a mistake. We are dividing both sides by sine x. We also divide it also by sine x. Yeah, sine x. That was a mistake, sorry. Now let's move on. So 1 plus y dy equals to cos x over sine x dx. Alright, so from there we just say that this will be 1 all over 1 plus y dy equals to our cos x all over sine x is equals to cot x. You understand that? It's equals to cot x dx, and now the next thing is, we will always find the integral of 1 over 1 plus y dy equals to integral of cot x dx. Okay, so what's the integral of this 1 over 1 plus y dy? That would be ln 1 plus y, ln 1 plus y equals to, then the integral of our cot x, it is written as ln sine x plus c. This is the integral of cot x, ln sine x. So from there, our c, let us say that our c is equals to ln a. Once our c is equals to ln a, we input it in this equation. That will be ln open bracket 1 plus y equals to ln sine x plus ln a. Ln sine x plus ln a. Let me just continue here. Sorry. So ln sine x plus ln, let me write it here. Ln open 1 plus y equals to ln sine x plus ln a. Okay. Alright, so from there, what we'll just say is ln 1 plus y equals, when you say ln sin x plus ln a, that will be ln a sin x. That is the way to be written. That's the way to be represented. It is still the same thing. You get that? Ln sin x plus ln a, you put your ln, then your a sin x. That will be ln, open bracket, 1 plus y equals to ln a sin x. And let's just continue by saying, if you divide both sides by this ln, if you divide both sides by ln, your ln will cancel each other, and that will be 1 plus y equals to a sin x. Now we are getting our y, which is equals to a sin x minus 1, and that will be our final answer. Kindly